Ohayo gozaimasu! Hello! Today I have a problem with my model. My host is no good. Too bad for the host, I will use my own solutions. Hello everyone, hello, welcome for today's episode about animals! And happy Monday. I haven't found a meme about Monday yet, but surely that will surely be something. Surely I will find a meme about the Monday which is not about Garfield in any way. How is everyone doing? Because I have a meme about Friday. I have a meme about wanting to be Thursday, but I don't have a meme about wanting to be Monday, which is a freaking shame if you ask me. Especially since it's a social construct that it's the first day of the week. Like in a lot of countries, Monday is the second day of the week, so Sunday being the first day of the week has other memes, but corresponds to what it is. It is what it is. It is what it is. But how is everyone doing in this beautiful Monday? Oh well. That is too bad because today we introduce ourselves to animals. 3 families of animals, as you will soon see. Let me look at it. Opisthokonta Part 1, Metazoa. Opisthokonta Part 2, Metazoa Part 1. Yes! Also, this can be really grating to my ears. So let me just find the properties of this one. Let me see. Which one could it be? We are soon in Halloween season now that I think about it. This one works. This one works really well. Oh yeah, it works. Not tomorrow. Not tomorrow. Only today. And yes, I am still here. Why wouldn't I still be here? Why wouldn't I still be here, my dude? But hi, H. It's nice to see you. It's really nice to see you. But yeah, I'm still here. I mean, what do you mean? Like, would I be gone? Would I be gone? Would you prefer me gone? Would you prefer me gone? Would you prefer me as good as gone? Is that it? Because it can happen. It can happen. I don't know. You announced to see 1.5 hours ago. That is true. That is true, but YouTube has the advantage of actually giving me waiting rooms, so I use them. I have waiting rooms. I haven't made the waiting rooms for the 2 other days, for Tuesday and Wednesday, because I still need to do the Wednesday templates for the Disco Elysium streams. Wednesday we begin Disco Elysium. But yeah, don't worry about that. I'm going to say something, and it's when I'm gone, you're gonna miss me when I'm gone. You're gonna miss me by my hair, you're gonna miss me everywhere. Oh, you're gonna miss me when I'm gone. Senza was reference. We love to have them. Okay, so today will be our first episode about animals, and we're going to be here a long time. Trust me on that. It's a glorified talking simulator. That it is true. As an Argentinian friend once said, indeed. Indeed. Also, the GIF is really weird. Like, I will try to fix the other problems with VTube Studio that I have today. But, yeah, it's weird that it doesn't react to my movement, you know? Because usually I use it as a mirror. I cannot use it as a mirror, so it's like seeing my own image moving and not exactly acting, which kind of hurts. Like it hurts my brain. It hurts my brain because there's a how to say, there's a lot of me that is now independent from me. If you know what I'm talking about, it's basically my image in the mirror moving by itself. It is super weird and confusing. Like the psychological aspect of VTubing should be explored more. Because this is weird. This is really weird. Also, I'm going to get some water for myself just before the talk. I'll be gone about 1 minute, not more than 1 minute. Shouldn't be a long class. I'd say 1 hour, 1 hour 30. We are only going to explore 3 classes of animals, so it's not going to be hard. To say in advance, hey, hello, I smile. Hello. Did I ping? Oh shit. I'm very sorry. I'm absolutely sorry. Hello and welcome to the Scuff stream. Because my VTube Studio refused to work. Most likely because I began the live before I opened VTube Studio. And you know what happens when you open OBS before VTube Studio. The camera just doesn't work. It just doesn't work. But hey, thank you so much. Hey, it's nice. It's nice to see people coming through the pins. I hope that you will have a great time. This is pretty much an educational stream. We are going to talk about animals today. Some good animals. Tomorrow will be the end, I hope, of Blasphemous 2. And the day after tomorrow we begin Disco Elysium. But for a moment I'm just going to get myself some water. Make yourself comfortable. Meet Dark and H, both veteran viewers of myself. You know, being a GIF is good, but it has a lot of psychological effects. It's weird. It's really weird. Like I said before, my brain is not adapted to see my own image move without me moving. It is really, really bad. Just let me get some water. I'll be here and I will begin class very soon. I do have to say that there's one advantage to being a GIF, is that I don't need lights. Like I don't actually need my camera, so I don't need lights. Meaning that I don't exactly. Well, it's going to be lighter on my electricity bill. So, welcome to this parasitic class, the 4th one. It's already been a month. Can you imagine? Last time, we saw Opisthokonta. We basically went through Opisthokonta. We just went, you know, through a really quick overview of the Opisthokonta in the Eukaryota family. Afterwards, I said to myself, we are going to explore animals, because animals we are going to explore in details. There's going to be 3 privileged, what I'm going to call privileged classes in the Eukaryota classes, and it's going to be Metazoa, Planta, so you know, plants, and fungi. So of course it's going to include true fungi who are also Opisthokonts, but are going to come after the Metazoa, after the animals. And it's going to include us, the Metazoa. And it's also going to include plants, which are our main source of food and the food of our food, if we intend to be meat eaters, which is a perfectly good way to eat. So we are going to see Metazoa. Metazoa being right there has evolved around 760 million years ago. 760 million years ago. It is pretty not recent, but you're going to see that there has been quite a few things before. Like we haven't gone like directly through mouse and fish at the very beginning. We're going to expose the characteristics of what is an animal. Well, an animal has multiple. It's a eukaryote. It's an Opisthokonta that has multiple cells. Most animals, if not all of them, are completely multicellular, and all these cells have a matrix of glycoprotein and collagen, which an extracellular matrix is basically the substance that you have outside of your cells. You are made out of cells, yes, but also of stuff that is not cells, including this extracellular matrix. So this matrix for medium, and extracellular meaning outside of the cells. Genius stuff. Here you have collagen fibers, and you have a protein that contains both protein strands and polysaccharides and carbohydrates. Well, polysaccharides and carbohydrates. Okay, so polysaccharides meaning that it's a chain of sugars. It is a chain of sugars that contains some protein afterwards that are literally attached to it, and these proteins contain themselves sugars. It helps with water retention. It helps with adhesion. My high school science is now useful. My teacher might be proud because I can recognize some words. Yay! Nice! I mean, that's my goal. My goal is to be a high school teacher, so hey. It's all good. But as you can see here, you see a classical cell to a double-layered membrane of lipids. You see the cytoskeleton that what we saw when I explained the sex updates in the eukaryote family. And of course, yeah, this lipid membrane, this double-layer membrane, is called the plasma membrane for the cell of a eukaryote. And here, specifically for an animal, because you saw an integrin that are linked to fibronectin, which are extracellular proteins of the cells, and the collagen being completely outside of it. Secreted, but outside of it. And by secreted, I mean the cell produces it, but it goes outside, it stays outside. It's field stuff that is very important because it allows your cells to travel, it allows to have communication, it allows to have a proper structure that creates a tissue. I mean, yeah, I think that's a cool goal. I mean, it's a very thankless job, but my passion is to actually share what I know, as you can see on this stream. So yeah. I mean, I also want to be completely honest. The pipe dream, the absolute pipe dream, is to actually be successful as a Vtuber. But for a moment, it's an absolute pipe dream. Also, another characteristics of animals. Nearly all animals primarily use sexual reproduction. The sex update is really freaking useful for animals and allow for a lot of diversity. There's of course exception of possible asexual reproduction, but most are outliers. Most of it, like you're going to tell me, yeah, but there's this one lizard that reproduces through parthenogenesis, meaning that all these species of lizards are all clones of themselves. Yeah, but that's literally one species of lizards, and I think that they are going to evolve into actually going to have males again. So the cloning strategy doesn't work. Like, cloning strategy doesn't work because sure, you're able to make a lot of you, but if you're all sensitive to the same stuff, you're going to die. You are all literally going to die. So It's not like with bacteriophages, where one of the bacteriophages could fail, and then you could learn from the quote-unquote mistake, and basically adapt yourself to that. No, you don't have those kinds of systems. You, as yourself, you don't have those kinds of systems as an animal. So clones, bad idea for animals. Very bad idea. And we also have a blastula embryonic phase stage. So what is a blastula? Basically, you see a whole sphere of cells. That is the embryon, as a morula. Morula meaning... okay, no cloning, got it. Yeah, no cloning. Cloning is a pretty bad idea. I mean, it's not a bad idea as in, oh no, it's so unethical. Oh no, what with the humanity? No, it's, if we have the flu, and your clone has the flu, you are 100% sure that you are going to be sensitive to the flu. Like, 100% sure. If your clone has any genetic problems, every single one instance of this clone is going to have genetic problems. Like, this is why eugenicism and cloning is freaking stupid on humans. Because we evolved specifically out of it for reasons. But yeah, so the blastula embryonic phase basically makes you into a beach ball. Ethics, what is that? I asked myself this question. It makes you into a beach ball. Basically, you have the borula, which means it's not the blueberry. What is like what it is? Yeah, it's a blackberry. Basically, morula means blackberry in Latin, if I remember correctly. In Latin. Yeah, no, so it describes embryonic stage. That is literally one of the first one. You have the cell. It divides. Basically, the egg is already that big because the egg cell, the female egg cells, are already like the biggest cells in the human body, or generally in any animal bodies. There's some differences. And then it divides, and when it divides, it actually uses the material that is already inside of it, so you have no augmentation of volume. The first divides do not create an augmentation of volume, but after a while they create a cavity, and this cavity makes you into a beach ball. This beach ball is the basis of all animals. Like, literally all animals have begun as a sphere of water, as a sphere full of water. And usually, less than 1 millimeter, only like less than 1 millimeter, they are about 0.2 millimeter. So visible with the naked eye. Egg cells are visible with the naked eye. That is how big they are. And they're kind of yellowish, like transparent. If I remember correctly. Yeah, it's 200. Yeah, it's 200 micrometers, so it's 0.2 millimeters. So it's pretty big. It is really big, at least in humans. The example that I know is with humans and mammals. That's what I know. Come on. Okay, so usually the cells arrange themselves into tissues. And how they will do it? Well, you have adherence between the cells. That is also another characteristic of animals. Is we have junctions between the cells, very elaborate junctions. Elaborate junctions, especially here we have the desmosomes. Here we have gap junctions, and you see gap because they can open. They can actually create a gap between the cells. The desmosomes, which are really specific, like really specific. And I think that this is called a Z junction. Let me like Z junction cells. Yeah, it's just called a tight junction. It's just called a zonula occludens, literally a tight junction. You know, it's just called a tight junction. And basically, the tight junctions, also called zonula occludens, work with epithelial cells, so the cells in your mucosae, the cells that exchange stuff with the environment, and they serve to basically make them adherent. Like they make them they create a great solidarity to create this tissue. The lumen is what we call is in reference to light, and basically the lumen is the cavity. The lumen is the cavity when we're going to talk about something. For example, this is the lumen of the blastula, and in tubes, the interior of the tube in biology is called the lumen. And you have the mucous layer, the apical side. The apical side is the side of the cell that is towards the layer in epitheliums, in epithelia, and you have the basolateral surface because you have a basal membrane. The basal membrane is part of the extracellular matrix in which your cells are going to be sat upon, and they are going to be they are going to really adhere to it. But the problem with that means that when you go into the world of animals, you have specialized cell types. That means that we will talk about cell types. When we talk about animals, we're going to talk about their specific cell types, and they are annoying because, like I showed you, they can be really complex. As a cell, for me, a cell is already extremely complex. So talking about like a group of cells that have a new emergent function through their organization and their geometry is freaking annoying because it just adds to the complexity. It just adds to the complexity. So multicellularity has been, and its consequences has been a disaster. What is the complex for that membrane? Don't get that yet. The context for that membrane, the basal membrane. The basal membrane is what separates an epithelia from the rest of the extracellular matrix. Basically, the basal membrane allows them to polarize. So they sit on it, and because they know where the basal membrane is, they can know that this is their ass. So they need to polarize towards this direction. And it's just like sugars and protein. It allows for the polarization of the cell. But yeah, that's the thing about, you know, the basal membrane. Oh, great. But yeah, here I'm only talking about an epithelium. The thing about epitheliums is that they are all polarized. They all are towards the lumen, and there's different types of epithelium. I'm going to show you. Yeah, I'm already on it. Like you can see, there's multiple types of epithelium. There's the simple squamous epithelium. Just call it a simple epithelium for now. When it's simple, you have a single layer of cells. You're pseudo-stratified because it's not stratified. It absolutely isn't. Like there's one layer of cell that all join towards the lumen, but they look weird, so we say pseudo-stratified. And then we have the stratified one, where you have one layer that sits on top of the basal membrane and one layer that sits on top of another layer of cell. And it can also be like higher. It can also go way more surface, like way more membrane. It's like, you know, on the skin, like literally on the skin. Afterwards, yeah, So yeah, cell types. They're annoying because they're never simple and there's always subtleties. When we're going to talk about specific organs and animals, there are always going to be some subtleties because, of course, they have to evolve this one function in a particular way, which allows them to have this with a certain property that is unique to them because they are freaking annoying. So we're going to have to talk about that. They're annoying. Histology, for me, has been one of the most annoying subjects of all of biology. I know that some people liked it. Personally, I didn't. I prefer my cells alone. Okay, so we're going to talk about 3 classes of life, 3 stratas of life, 3 clades, Porifera, Ctenophora, and Cnidaria. Today, that is exactly what I want to talk about for now. Porifera, which refer to sponges, jellyfish, and common jellies. You will see that you will learn that we are going to see like the most gelatinous animals yet. They all have this one thing. They all have this one thing where they basically don't exactly how to say, like they're still in this class of animals where you don't really exactly, like the great public doesn't exactly consider them like animals. Especially, except if you watch SpongeBob, you don't really think that Cnidarians have exactly the most like profound lifestyle. You don't really find them interesting or complex in any way. Compared to anatomically, they might not be, but they do have their complexities. They do have stuff that makes them interesting. You will see that they are also. Maybe they are simple, yes, but they are also extremely successful. And something else that is extremely interesting about them is that you see that there is a class of life that we call the Parahoxozoa, and that is because of the Hox genes. The Hox genes are something that basically dictates the chronology of embryology. So the formation and the development of an organism can be arranged using biological clocks, what we call the Hox genes, that allow for different architecture within an animal. Both of them, they don't have that. But when we go into Cnidaria, we see that they begin to have this kind of organization. They begin to be associated with these molecular clocks, which allow us to see like that you don't exactly need a molecular clock to be as complex as you want, because Ctenophoras do not need them, like the common jellies do not need them. However, it is a stepping stone if you want to go towards a more quote-unquote complex forms of life, as animals are basically specialized in anatomical complexity. Since they go towards multicellularity and they have a very active lifestyle, they need to be anatomically complex because they are bigger, and meaning that they are bigger, they have more energy needs. That means that they can't exactly use most of their nutrition to grow, but to move towards searching more energy for moving. It is kind of a vicious cycle, but it works for them. I mean, it seems to work for them. So for now, we're going to talk about Porifera, also called sponges. They differ greatly in size. They can be a few millimeters long and large, or they can be like, as you see, about human sized, to about 2 meters, 3 meters. Sometimes they are even bigger than that. But this is clearly in the extreme when it comes to sponge sizes. But they can be extremely big, or they can be extremely small. Like this is a great zoom up, because you see that for the algae and all that. So they cannot be more than a few centimeters long. They can be more than a few centimeters tall. Porifera all have about the same anatomy. They have about the same cell types. That's not good. That's not good. That's not good. That's better. That's better. That's better. Yeah. Ah, it's only because of this one. That's only because of this one. Scheisse. Yeah, that's only because of this one. Yeah, I'm sorry, because there was a comment page. Sometimes I do comments when I create something, so that's why. That's why it happens. Okay, so under me of the sponge, you see that there's this kind of jelly called the mesenchyme. It's jelly. It's the extracellular matrix. You have conocytes that looks a lot like the choanoflagellates that we've seen last time, that are the glass weavers. This thing there's no glass here on these choanocytes. You have sclerocytes that participate in the act of biomineralization. So they create mineral matter. And what are they doing? They're creating spicules that create like some kind of skeleton for the structure to actually stand on, to create some structure, some rigidity, to allow to have this complex tall shape that fights gravity. Because even in water, if you don't have anything, you won't be able to fight gravity. You have amebocytes that are from, like I would say, unspecialized cells that just float around and eat stuff, and when they're needed they transform into a cell type, into another cell type. And you have a pinacocyte. The pinacocytes are basically the skin cells of the sponge. They are basically the skin cells. They go inside, they go outside, yes, but sometimes they also go inside. But it depends. Usually they are only outside, because they consider the rest of it's for the sponge to consider the rest of the environment like the outside of itself. And you have the porocytes that creates the holes, the holes of the sponge. And then because the most important thing that you will need to find in a sponge are the pores, which is why we call them the porifera. The porifera, fera for animals, and pori for the pores, for the ostiums, for the ostia. What are they used for? How do we create the water flow? Because they just float. Well, that's where those cells come into great use. They have a flagellum, so they just swim around. But since they're attached to a living structure that is, literally rigid, like quote unquote rigid, they can't move. So action reaction. If they can't move, all of the movement goes inside the environment, inside the water, so they create a water flow. But it's entirely how the water flow is created inside of a sponge. They have just little ciliae, flagella, but they swim around. They have cells that try to swim around, but they do it unsuccessfully. It creates a water flow, and they eat. They eat through that because the fresh water usually has some food particles. So they are most of them filtrates for food. Like they do their thing. They filtrate. So they're very happy about that. So yeah, it's basically a living gelatin sandwich with glass shards inside. Because they ultimately, when they biomineralize, they create those spicules that can have different anatomies depending on the sponge species. They can be made either of calcium carbonates or of silica. So glass. It depends on the species. So there is a genus of sponges that are only made of glass weaver. So there's the glass weaver sponges. They exist. They're usually found. They're pretty rare. I mean, I find them pretty rare, and they're usually found to, I will say, great depth. At least 1 kilometers inside the 1 kilometers. Like you have a water column, you have at least 1 kilometers deep. So we have a problem here, and I'm going to expose to you this problem. You have this anatomy, and this anatomy is exactly the same for the sponges. So that means that for 1 gram of sponge, you're going to be able to only feed a certain amount of sponge. Like, let's say that for 1 gram of sponge, you're only able to go to 1 gram of sponge. Problem is, sponges are prey to a lot of species. They are prey to a lot of species. And one of the main defenses that you could go to be not eatable, like not die through this process, is to just be bigger. You can just be bigger because sponges, they don't really care. There's no real tissue. There's no real coherence between the cells. And any cells can become any more cells, and any other cell type. So if you take a chunk, if you take a part out of a sponge, you don't have a dead sponge. You have 2 sponges. You have one wounded sponge, and one really wounded sponge that's going to become another little sponge. But here's the thing: a certain surface of sponge can only feed a certain volume of sponge. So what do they do in order to feed more sponge? In order to go to this massive, incredible size? They just increase the surface. It is exactly the same anatomy as what you see here, except that they just create more surface and they become thicker, meaning that they become harder to eat. And that's how they do it. The water flow stays about the same, because the choanoflagellates, they of course it needs more nutrition because there's more living matter inside, but the choanocytes, like the thing with the flagellum, they always work at 100% efficiency. So you just need to have more surface of them. The water flow doesn't really change. You just have more surface, so you have more water inside, and it just filters more water, you know? It just filters more water mechanically. You have more surface, you have more better efficiency, and you filter more water. So you're going to say, yeah, so you said that animals usually they move. And I said that they had an active life. That is true. Sponges are not exactly known for their active life. That's because you're thinking about adult sponges. The larvas, which are in blastocyte form, like in blastula form, like I showed you before, like the literal, you know, the literal water balloon, the little beach ball, that literally is a sponge with a hole inside. Like a sponge is just a beach ball with a hole inside, and holes around too. Well, when it's a larva, it is also a water balloon, and it just floats around, finds a good spot, and becomes an adult. You know, it grows. The feeding habit of sponges is that it filters food inside of water, and sometimes, and we don't exactly know how, they capture and they feed on prey. Crustaceans, small fish. It's not even plankton. Like it's actual big animals. Like what you consider like an active big animal, like actual crustaceans, actual fish. Like if I don't recommend that you put your penis inside of a carnivorous sponge. Like I don't know how agonizing the process would be. Like I don't know. But let me show you an example of a carnivorous. Most of the carnivorous sponges are found in deep sea, and yeah, over crustaceans they're called like hooks on external body surface. Oh yeah, so basically it uses why would you even do that? My dude, the Welsh exists for a reason. And they made me learn that they made me learn that if you find a structure in nature, a human is going to try to put their penis inside. Or they're going to try to put it inside of their ass. This went some cell-type sponge to blowjob really fast. Yeah, but carnivorous sponges don't exactly look like that. Carnivorous sponges, they look more like that. Oh shit. Okay, let me show you. Let me show it to you. They look more like that. Like this is called the lyre sponge. Because of the form, it looks like a lyre. You know, the musical instrument. And And when it has, you know the spickles, you know the hooks. It has literal glass and or rock hooks that it uses to capture its prey and digest them. Just like a freaking carnivorous plant. So it doesn't move, but it's still able to capture its prey. And it can be also this one. This one is also carnivorous. Like this is a sponge. This is a sponge. But yeah, it is. They are usually like carnivorous plants. They are in nutrition poor environments, so they capture prey in order to fix that. So yeah, you have deep sea carnivorous sponges. And the reproduction methods are pretty simple. Fragmentation. So you tear a piece of a sponge, and since it is undifferentiated, all of the cells are not independent. But you know you have a chunk that is big enough. It can make another sponge. Budding. So they naturally prepare a part of themselves into another individual that is going to detach itself. Gemmuling, which is budding with extra steps. It makes like it's basically budding but with the beach ball step. And then with sexual reproduction, which is basically like it's really weird. The way they do it is really weird, because it takes a massive advantage of its anatomy and of the sex update. So imagine all of those combined with the sex update. You have one cell that becomes like sperm cells that are going to be ejected inside another sponge. Since it filters the water, the sperm cells are going to go inside the water flow, being captured by choanocytes right there. They are going to be recognized and captured. It's going to enter, go inside another cell that is specialized for that, and then fertilization will happen. But sponges are weird because, as you've seen, since every single cell can become another type of cell that is completely undifferentiated and nothing is specialized, and you see that they look like our nearest cousins, the choanoflagellates, you would think that maybe they can have an independent life. It's not the case. It's not the case. You take a single choanocyte, it's going to die. So they, in having this obligatory multicellularity, we lost something. We gained something, but we lost something compared to our cousins. And now we're going to talk about the Ctenophora, the common jellies. And now I think that this episode is going to be really short. I mean, I will answer questions then. I will just answer questions. So, common jellies. Common jellies are kind of rare. They are really dispersed, and we think they're pretty ancient. They're kind of still a mystery because there is this problem in which we think that they are the remnant of how the first organism with tissue was, but we evolved out of the things that it did, and then we re-evolved them again. So I put them, I use the Wikipedia one because I agree with the fact that we can categorize them using the Ox genes, but they're just weird. They're just weird, absolutely weird. Classifying them is really hard. And the most important thing is that they have an anal pore. It's important, yes, because when you look at jellyfish, for example, they have a mouth, and this mouth also serves as an anus, and it's completely not different. It's not different. You will see when we're going to go to cnidarians. To cnidarians. Those, they have an anal pore that is specifically created. So we think that the anus evolved and then reverted and then re-evolved again when it was needed. With them, we're beginning to see tissues. We're beginning to see a nervous system. We're beginning to see muscle cells because there's movement. There's absolutely we can't deny that those things move. The cells, they keep the same function. So you cut a comb jelly in half. You're going to have two dead halves of comb jelly rather than two comb jellies. And they do have sensory organs. Do they have eyes? Are they sensitive to light? No, they do not. But they still do have sensory organs. So they can still react to the touch and to other stuff. So they can be active predators. They can actually become active predators. And yeah, because all of them, pretty much all of them are predators. And now we're going to go to an apartheid that is going to be talking about the nervous system. Because the evolution of the nervous system is really weird. This is a paper from 2018, so I'm sorry that I haven't found a paper that is more, that is more actual, that is more about actuality. But I don't know if it evolves, if the subject of neurology evolves that quickly. I hope not. I hope not. If this paper is already terribly outdated, like 2018, it's literally the prehistory, you know. But you have this cnidarian / bilateral ancestor, because you're going to have what we look at symmetry. Symmetry is one of the greatest, like one of the most drastic adaptation measures that were taken during evolution. And you see that there is this net. There is what we call a neural net. So the nervous system is very dispersed. It's very dispersed for cnidarians and for ctenophores. Yes, the C is silent. Yeah, it's not only in French and in other languages that we can have silent letters. In English too. But then we'll see like you saw that the OX genes basically become active here. So you see that there is this neural net, but more and more you see this other organization in chordata, so in vegetarians, sure, in deuterostomians, but also in prostomians. Protostomians and deuterostomians, we're going to talk about them in the are we going to talk about them in the next episode? Yes, we're going to talk about them in the next episode. They have a very clear difference, and this extreme anatomical fundamental difference that changes everything between deuterostomians and protostomians is the formation of the anus. When it's formed, the anus either comes first or it comes second. So either the mouth forms first or the mouth forms second, with the anus first. With us, like the deuterostomians, like mammals, fish, like eels. You could go with something that doesn't have a jaw, so lamprey, etc., etc. Because we are all weird fish. All weird lampreys. The anus forms first, and then comes the mouth afterwards. In protostomians, so more like insects and annelids and all that, the mouth forms first, and then you have the digestive cavity, and then the anus. So we kind of made bird first, which is weird. But it's funny. It's funny because some people when we learned that some people were really like kind of surprised / some even were offended because apparently they associated the fact that you would have a mouth first with being quote unquote more evolved. Well, no. Anus comes first. Anus very much comes first. And you have different anatomies with comb jellies. It's not like it's a group. And we call them common jellies. They don't really have a lot to do with jellyfish. Well, jellies in general. Like it's only because they have gelatin inside of them. You know, they have this mesoglae. They basically are this sandwich, this cell sandwich, in which you have this gelatin sandwich, in which you have cells to make the sandwich, to make the bread of the sandwich. Well, they're pretty much the same. You see the anal pores here. You see the mouth. They have a specialized mouth. They have specialized anal pores. They have indeed a stomach. This is a pharynx. They have a pharynx. And what defines the ctenophores is the combs. You see the combs here. You see the combs here. You see the combs there. They are near the mouth. And sometimes they're used for moving. Well, I mean, they are used for moving. But they are also used for nutrition. They are also used for nutrition. And something that the ctenophores and the cnidarians can share is the presence of what we call the nematocysts, that we're going to explore when we are going to talk about the cnidarians. The nematocysts are a specialized type of cell that really do define some of them, which is why we thought at first that they were like related to jellyfish, to jellyfish and other cnidarians. They're not. Like, I mean, they kind of are, but they're not. Like they're more the sponges are near cousins to them than they are to jellyfishes. If you know my meaning. And yeah, this one is just a mouth. This one is just like an enormous mouth, and you have a big stomach. It moves, and it can kind of chew. It can chew a bit using the comb. But that's about it. Like this one's just a mouth. And as you've seen, a lot of them are actually bioluminescent. A lot of them are actually bioluminescent. Yeah, like you see, they're kind of cool. And that's how they move. You see the movement of the comb here. And here you see the mouth, and you see the anus. Or maybe that's the mouth, and this is the anus. Because you see that this is the mouth. This should be the mouth, and this should be the anal pore. You could see the anal pores there, I think. I could be completely full of shit there. I am absolutely not a specialized, and absolutely not a specialist. However, as you can see, they are beautiful. They have an intriguing beauty about them. They have an absolute intriguing beauty about them. As soon as I learned about them, I immediately fell in love with them. Because they're just plain weird. They're just plain weird. But yeah, here's the thing, they're not really jellyfish. That's the thing, they're not really jellyfish. They kind of look like jellyfish, but they're not. Like I said, they're more removed from jellyfish than they are from sponges. And yeah, that's like here we go. It's actually kind of cool. It's actually kind of cool, you know. I mean, like it's literally like looking. I mean, it's not exactly what you would associate with the most active state of mind, but it's kind of cool. I mean, for me at least. For me at least. And then you have the cnidarians. And the cnidarians, they're going to have a part 2, I think. I think they may have a part 2. And cnidarians, they are basically everything that you know as anemones, as coral, as jellyfish, and as hydras. They are really powerful predators that they don't exactly think. And there's two body types. Like they actually have two body types, sometimes that they use in the same lifetime, which is the medusa and the polyp. Sometimes some species are restricted to a polyp type, some species are restricted from a medusa type, and some species go interchangeably through both of them, like both types. The polyp type is sessile. when I say sessile, I mean that it is a fixed lifestyle. It has a basal disc, what we call the foot. It has a foot. It stays on its foot, and it takes whatever food happens to go there. The Medusa face actually uses its muscle cells to go directions. It actually uses its muscle cells in order to move. And here's the thing about Cnidarians: they don't have an anus. They don't have an anus, so both the mouth go into a gastrovascular cavity. They digest it, they digest it, and then they poop from the mouth. They literally poop from the mouth. Because they digest, they absorb into the mesoclay, which is the jelly, the jelly of the fish, the jelly of the jelly. And they do that. They have two cell types. I mean, they have two main, quote-unquote, main cell types. I mean, two main tissues, rather. Two main tissues. The endoderm, that is into the gastrovascular cavity, and the ectoderm, which is basically the rest. They do have a pretty interesting way to have of neural nets, especially near the mouth, that they use in order to, you know, move their mouth. But they can do. They can actually do that. They can be really, really small, or really, really fucking big. As you know, giant jellyfishes are extremely big. Can be at least 2 meters long, I think. Like, what is the longest jellyfish? Like the longest jellyfish. Largest jellyfish in the world. Oh yeah, no, they can be absolute. Oh shit. Yeah, the lion's mane jellyfish. What the heck? Yeah, no. I want biggest jellyfish. But what I do is basically they capture you. I mean, I would just want a giant jellyfish. Yeah, they can be really fucking big. They can be really, really big. Oh yes, if you need, you need much more nerve than if you sit around and wait for food. Depends on how you capture your food. Yeah, this is a giant barrel of jellyfish. You see, compared to a human, it can be really, really big. It can be really, really big. Like, let me show it. It can be really, really big. And they have this specialized. They have this lifestyle that is weird. Let me tell you why it's weird. Skin capture and up into proper capture. They have this lifestyle that is really weird, really weird, because they can have a reproductive cycle that can go this way. Okay, so I'm going to explain to you. They have this colony type body plan, where they all share the same resources, and they make their thing. They are in hydra form, as you see here. They are in hydra form. They eat. Sometimes they are specialized individuals for sex, for nutrition, for capturing prey, etc., etc. They are all linked. They all share the same nutrition. They are a colony, and they are, you know, they're kind of in between an individual and multiple of them. Like, you can't really make the distinction between them and another individual, since they are like they share the same things, and they also share reproduction. But sometimes you would think that maybe they are more individual, sometimes they're not, which shows that individuality in an animal is actually a spectrum that this thing is capable of breaking. Like, this thing is capable of breaking, and this is if you've seen the Portuguese Man of War, which is another type of jelly, like which is another type of colony type of organism. It's basically the same organization. Like, no, it's more like, you know, there's multiple cells, there's multiple individuals that all have functions. They all are made of cells, plural, but they also have a specialized function, and they are even reproductive ones that are entirely devoted to reproduction. So, who knows? The multicellularity, the advent of being an individual is not really as clear-cut as some people would think. But they make this colony, they can bud, so they bud exactly like a sponge would, and make this medusa. This medusa is then capable of sexual reproduction, make an egg, make a larva. This larva can make another colony, which will then repeat the cycle. Or, it does that, egg, larva, medusa, egg, larva, medusa, egg, larva, medusa. It stays like that. Or it becomes that, stolen, egg, larva, stolen. Like, hydra, egg, larva, live, hydra. Hydra, egg, larva, hydra. The immortal jellyfish does this cycle. But it can also revert to this cycle. It can also revert to the metamorphosing larva through the medusa and go inside the hydra, which makes more of itself to become another medusa. And it's easier to retain in French because we call them meduse already, like medusa, meduse. So we're cool with that. And yeah, that's how they work. They're weird. And they have this one specialized cell called the nematocysts or the ctenocysts. What they do is they have this was ctenocyl. This is a seal. It is able to feel pressure. It is able to feel pressure. There is negative pressure inside of this zoom. There is an operculum, yes, and inside there's negative pressure. So it is always under pressure, and it is completely. I mean, there is pressure inside, but you can't exactly like for a moment. It's unresolved. It is unresolved. It's also upside down. Like you imagine that it's like a glove. And the glove, you actually reverse it. It's like a reverse glove. So everything is inside and everything is upside down. The ctenocyl is activated. The operculum jumps. So pressure can be liberated. The pressure can be resolved. And since the pressure is resolved, it pushes the thing itself. It pushes the thing from itself, creates water pressure, and penetrates within the organism. It has a harpoon, yes. And can infiltrate the tube inside, which will then, and the barbs, of course there's barbs, and another pair of barbs, of course there are. And they transmit the neurotoxin that in which this thing is coated by penetrating the skin. It is absolutely vicious. There's multiple forms of them. Like there's multiple types, and let me tell you, it is absolutely vicious. It's an extreme weapon, and as you know, since cube jellyfish are a thing, can be extremely deadly. And I wanted to show you some hydras because they can be extremely small. Hydras are extremely small. Like when we do colonies, they can be extremely big, but usually they're extremely small, and they can live in both freshwater and inside seawater. Medusa, you only see them in seawater. You only see them in the sea, as far as I know. I have never known about a freshwater jellyfish. However, hydras, you can them anywhere there's water. You can find them. And they're usually like the biggest microscopic residents, but they're still microscopic. They're still there, they're still chilling. They eat food particles, they're all nice. And of course, the The most famous cnidarians and one of the most ecologically, I will say, quote unquote, ecologically useful are the corals, which are just the association of a polyp, so a hydroform, like literally a polyp form, a hydroform, that is minuscule, and an algae that provides it with all of its nutritional needs. Of course, it's a colony, and what they do is that they create to create more room for itself. It basically creates a calcium. It creates a calcium shell where it builds upon itself. The colony builds upon itself, etc., 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 creating more and more elaborate shapes. And you basically have a photosynthetic, like you basically have, well, corals. Well, that's all they are. The main why are corals dying now? It's not only because they need they need both a very specific temperature range and temperature pH. Because the main problem with corals, with climate change, is that having more CO2 into the atmosphere makes it that both the water becomes way hotter, and hotter water contains less oxygen. Like that's mechanical. Fresh, like colder water is able to contain more oxygen. Hotter water has less gas inside of it. Has less gas capacity, so it contains less oxygen, which is bad for the animals inside. But the problem is that more carbon dioxide into the atmosphere makes that more carbon dioxide actually dissolves inside of the water. Carbon dioxide can become carbonic acid, like mechanically, like it lose a hydrogen, becomes carbonic acid, and so it will need to interact with another ion in order to keep its electrical stability, its electrical equilibrium. So it will of course go towards the negative calcium carbonate, which will then deprive the coral of the capacity to create its home. The acidity of the water makes it very fragile organism die. Makes it die. And that's why corals are dying. Also, we have invasive species that prefer to have hotter temperatures, and corals are not adapted to fight them, and they die because they get digested alive. That's coral for you. I mean, I also have a video of an anemone. Anemone moving. Like you would think that having a fixed lifestyle would actually make you more prone to be sensitive to the environment. Well, anemone proves to you that when they have predators, they are perfectly capable of moving. Like they are perfectly capable of actually avoiding predators. So you see, this is the predator of this anemone. If it comes into contact with the anemone, it's going to catch it, it's going to eat it. So what does the anemone do? It detects the predator, goes inside of its foot, and says to itself, "Fuck this shit, I'm out. Fuck this shit, I'm out. No thanks, don't mind me. I don't wanna be here." Which, both for the star and for the anemone, is pretty much blinding speed. Like this is blinding speed. And you see that the anemone is capable of moving, capable of relocating, and getting to a new spot. If it doesn't have its nutritional needs required, or if there's a predator. It doesn't exactly like to do that because, as you can guess, well, it's an emergency case, it's an emergency scenario. But it's not very much possible. It looks unnatural. No, it doesn't. It's perfectly natural. I mean, it's one of the oldest one too. It's like one of the oldest one. I mean, you haven't seen a sea star moving. I mean, yeah, they do that. They do that. They're pretty active. Come on. It swims! But yeah. 2013. You dive, buddy. But yeah, for something like anemones are also predators, of course. Like they eat a lot of fish, you know. They have this association with a clownfish that lives inside of their anus, inside of the mouth anus. They're pretty cool. They're able to react, but you see that they have a much more active lifestyle than what you would believe for a sea anemone. Oh yeah, absolutely. Like it is very conscious of itself, and I think that they have eyes. Like sea anemone. Do they have eyes? Are they capable of detecting light? Yeah, none of those are bivalves. Sea anemone eyes. But yeah, they are venomous, and apparently they could maybe the venom that they produce could have some properties, could have some interesting properties. But let's be completely honest. Sea anemones are also absolutely gorgeous, and I want to think that there was a world where most of life, like, looked like no, this one. Like, well, that there was a world where most of life looked like that, but you had this very weird world where you had some life. Ignore the shrimp because we're not there yet. We're not at crustacean yet. But yeah, it seemed to evolve over crab. Yeah, because it's able to detect it. It's able to detect it. Yeah, they are absolutely gorgeous too. Like you can have sea anemones going into colonies, like absolute colonies that are vast. And you for the fish, that's like a place where they can't go, because of course if they go inside they get stung and they die. Well, I mean, not for like, you know, for clownfish. Clownfish they actually love it. But yeah, they can colonize things. And you know that they sometimes associate themselves with crabs. You know, with the boxing crab, the crab with boxing anemones. Boxing crab. But yeah, there's the boxer crab and the glove, because the sea anemone can be used as a glove for the boxing crab. The anemone gets security because it gets the crab, so the crab allows them to move and so have more filtered water and more prey. And the crab, well, the crab gets the poison of the sea anemone. It gets the sting. So the crab can get the thing, you know. Can both get the thing, and the sea anemone gets something. So it's kind of a symbiosis. I need to do a symbiosis episode now that I think about it. Like a symbiosis episode. Imagine sentient corals just sitting around discussing shit for all eternity. You would never know. Especially since corals are also in what I would call the spectrum. Like corals could be inside of the spectrum because you see here that they are linked. They're a colony. So they are in this limit between a single individual and multiple of them, because you're going to be able to break some coral in order to make new coral. Like you can do that. You can actually do that. You can seed some coral. You can seed some coral with, at least, you know, you still need a certain quantity of it. But yeah, you could imagine that you could have a sci-fi story where they all share the neural link, and that makes one big brain coral leaf. Like, just sentient of what it is, what it houses, and its role in nature. And that would be poetic. For me, that would be an extremely poetic life. Extremely tragic, now that I think about it, because there's nothing we could do. They're extremely fragile. And there's a lot of species that do eat coral. Like, there is coral eaters. Like, some fish are specialized in that. Sea stars specialize in that. Yeah, there's a lot of it. And you know, when the coral dies, it only leaves the skeleton. It leaves the calcium carbonate skeleton, which is bleached white, So you have a massive coral reef that due to the water acidity, pollution, and predators can be completely bleached and die. Rather than having these fancy, enormous, ginormous, great colors. Yeah. It depresses me a bit. You know what? That's fine. For a moment, we have seen these three animal categories. We have seen these three animal categories, and I believe that it's alright, and that we're going to see three more. I think that we're going to go to bilatera, and we're going to see the core data, so the animals, like the actual core data animals, soonish enough, like next episode. But I would like to interest myself into more of the potostomians. So the plan is to go to the potostomians. So the one that evolves a mouth first, explore them, then go to the deuterostomians, explore them, and then we go to see fungi. And after we see fungi, we go to see plants. And after we see plants, and I think that there's going to be a special, either a Saturday or a Sunday or any other day, to explain symbiosis, to explain parasitism, and to explain commensalism. Like just a special episode, just to explain that. So it's not going to be a numbered episode. It's going to be a special. It's going to be the special 0, and we're going to go see that. We're going to go see that because it will be very important in the relationship between the animals and the things that we're going to see soon, very soon, because the most interesting relationships are going to be a relationship in associations with that. Symbiosis, competition, parasitism, and commensalism, which is just living in the same space and, minding your own business. For the moment, I think that's it. I think that's it for a moment. I hope that you liked it. If you have any questions, I think that we're going to have a 10-minute question segment. If you have any of them, just ask now. It is. I am very excited to be excited. I'm very excited to be able to answer your questions, and we're going to be doing that. Yeah, we're going to be doing that. Let's go. Yeah, we're going. If you have any more questions, if you want me to redo something, if you want me to deepen a bit of a subject, or if it's about another parasite class from before, you can ask away. Ask away. Just ask away. That's the question segment. I'm going to call it exactly that. I'm going to call it the question segment. Ah, it's a question segment. No. A question segment. We'll just have a question segment. So we're basically at the end of class, and you have everyone that we have everyone that basically is studying up material and all that, and you still have a question. You go to the professor and you ask away. You ask away. That's very simple. Sometimes you even have a good conversation, and sometimes you even comment hasn't been posted. No. So good. So if there's any question, don't worry about it. There's no question that I consider stupid. I'm going to answer them with exactly the same sincerity as I did this class. Let's have a biology question, more of a getting into biology one. I've already fantasized a bit about in that of its yeah. And I threatened to ask directly. Yeah, I saw that. Let me look at the question that you had in the other thing. Oh, synthetic biology. Nice. Very nice. Let me look at it. Let me look at the question in that other place. In tech. So you want to do synthetic biology? That's kind of nice. But I don't know anything except that biology is wet. I mean, if you want to do synthetic biology, you're going to want to know a bit about biochemistry. Biochemistry is going to be your most important friend, and so is going to be genetics. Do you think it's a good idea, or should I stay with my electric don't wet stuff? No, because there can actually be some meaning points. Like biocomputations are a thing. You could basically work in biomathematics, biocomputation. It is really well paid. You can stay with your electronic stuff while analyzing results of wet stuff. In which case, well, the most important thing that you would do is learn statistics, programmation, and other stuff like that. If you want to actually go for actual wet stuff, it's going to be a bit harder. Like, it's going to be harder because I don't exactly know what you could do. But there is this thing with microfluidics, like microfluidics in biology. Let me see, microfluidics, biology. Yeah, microfluidics for biology. If you want to work on wet stuff, like actual wet stuff, yeah, statistics, or you could work on wet stuff like do I have this? No. Do I have this? No. Do I have something akin to that? Something akin to that. You can have chips akin to that. So it can be extremely useful. Microfluidics is really useful. You could also go into genetics, you know. There's the interface between computation and actually electric science and biology is going to be more and more applicable. You could try to be a contractant for an enterprise, because I don't think that an academic would actually like count on you depending on the stuff. Of course, I think that they would want you to be able to manipulate the wet stuff, and for that you would need kind of an education in the wet stuff, or at least prove that you have some experience with the wet stuff. You would need that you are at least able to work with the wet stuff. Sterility is very important. So is the capacity to work without actually injuring yourself and injuring the sample. But if you want to go into bioinformatics, it is a very open field, and it's pretty good. If you go into that, you basically, well, you analyze results, and that's about it. But that's still extremely important. That is still extremely important. Like, you can resolve actually extremely important stuff. So usually bioinformatics is more about learning informatics for biologists, but I think that doing the reverse could work. Like, justifying of the reverse could actually work, and you would be in demand. You would actually be in demand. I don't know in which labs, but you would be precious. Like, you would actually be precious. And if you want to do more of the wet stuff, I mean, that works too. Because being a pure biologist is less and less applicable and less justifiable each and every day. Afterwards, I don't know. It's about the opportunities that you find. Unfortunately, it's basically all about the opportunities that you find for yourself. Any other questions? Bioinfo 1 next year. It's only a free CT2 course, so why not? Yeah, why not? Only free? Ah, so it's only a single class. Okay. But yeah, you're mostly going to learn a lot about statistics. You're going to learn a bit of R. Unfortunately, they really love to use R in that kind of thing. But bioinformatics is the kind of thing where you make the macros. Like it takes like 4 hours to make the macros, and then you basically then do 10 minutes of work each and every day. And afterwards you make more macros, and you do that again and again and again. What pulled me in was Prof talking about how they essentially build logic secrets in cells. The same but difference. When we do it in chips, how goes that shit? But yeah, if you want to actually go into biocomputation, like that's another thing entirely. Like that's more into biomaterials, I think. Depends. Like I'm not exactly with this world. More a Python guy, but R is fine. I mean, as long as it's not C++ or Java, that's cool. As long as it's not Java, that's cool, in my opinion. Unless C++. And C hash too, that can be interesting to learn. But you know what? You know what would be even badass? You make your biology program in assembly so each and every machine can actually work it. So each and every machine can actually work can actually make it work. Like is it Mac, is it PC, is it Linux? I don't care, it's in assembly. Go fuck yourself. Just install my program. But yeah, you're going to do a lot of analysis. Of gene expression, mostly gene expression, and if it's microfluidics, you're going to see like the expression of stuff. It's going to be a lot of statistics. But since it's going to be a lot of analysis, you're going to see a lot of things happen. Like I'm sure that you could get a lot of experience, and I don't know how to create a genetic computer, because that has been done. There has been one that was able to win at tic-tac-toe, but took like 15 minutes per iteration, like 15 minutes per move, which was kind of bad. I mean, bad. If you want to have 15 minutes per move in tic-tac-toe, you're kind of lost. It doesn't really work. I mentioned that I'm almost done with my masters without understanding statistics. Oh god. Well, good luck. Good luck. Because it's mostly that. But yeah. Yeah, it's cool. It's cool. It works. It works like that. It works that way. And I took a class on AI last year, and they actually had a task about basic statistics. I just tested that. Oh no. Oh no, you know that biology is mostly statistics, right? Like we don't have absolute results. We work with statistics there. Because we need to note not all cells are equal and they won't react equally, so we always work on populations. Ah, shoot. Took a class on AI last year. But, well, I think, yeah, but don't worry, it's not that advanced. It's mostly the Cairo test, some of the biology, some of the statistics that are completely normal, like, how is it called again? Poisson, Cairo test. It's but insert I'm in danger meme. Yeah, don't worry, I finished my master's degree I finished my master's degree without understanding statistics. I mean, I was bad at statistics. Like, I'm good when I have a fascicle and I know exactly what I do with the statistics. But ask me to do statistics by myself, and I'm kind of lost. I mean, I know how to interpret them, but it's at least like that. No problem. No problem at all. No problem at all. I'm here to help. I'm here to help and to educate. But yeah, I think that will be all for today. Tomorrow we have some Blasphemous 2. Hopefully with me being animated, and that will be the end of Blasphemous 2. The day after tomorrow we have the glorified talking simulator Disco Elysium on YouTube. And after that will be Armored Core on Twitch, and Saturday we will do on Twitch an actual writing stream, in which it will just be me, Zatsudan, me writing and discussing about stuff. So thank you. Good luck, high five to you too. Good luck, high five to you too. It was an absolute pleasure to have gave you this class. Don't worry, there will be a hypercut eventually in the future. And I was Guregan, the Parasite Vtuber, and I'm going to see you tomorrow. See you, bye! Actually, that's not actually. Yeah, that's not actually the one. Yeah, here we go. That's the one. That's the one. That's the one.